So when it comes to student T, where does this pooled S come from? So we get this weird equation that it's S1 squared N1 minus 1 plus N2 minus 1 S squared 2 all over N1 plus N2 minus 2. So where does this come from? Well, the better way to think about it is the variance. So the pooled variance is going to be the variance 1 plus the variance of 2. But the thing is, we're trying to calculate a new average variance. So we've got the S1 squared of whatever data set 1 was and data set 2 is. So if we multiply it back out by degrees of freedom here, now we have the total variance between the sets. And now if we want to work out what the average variance is, we just add the degrees of freedom together. So we get N1 minus 1 plus N2 minus 1, which will simplify to N1 minus 2. And then we turn around and we take the square root and get our SP back. So why is SP showing up in our student T calculations? Well, let's kind of think back again to what a student T value tells us. So at its root, your t-test, one value minus another, all over the whole variation, and you're typically going to have, depending on how you're calculating the full variation, one more term up there. So effectively what your t-value is telling you is that we want to compare the difference between these two as if they are a variance, and see how that variance compares to the sample variance. Now, if xj is just one data point or an average, we don't need to worry about it. We just take whatever the standard deviation, whatever the variances of xi is. But let's say we have two independently measured numbers and we want to compare them. Well, the thing is that their variances are going to compound. So we have to kind of put their variances on the same footing, and this is where this pooled variance is going to come in, is that it's going to combine the variances of both into a more grander, broader variance. So instead of treating them like, well, we've got this one data set with one variance and this other data set with other variance, we're going to act as if, well, let's say they came from the same data sets. What would the variance be? That's what SAP does. It treats them as they're coming from the same data sets. And again, the interpretation here is still going to hold that this is going to say, well, if we took their two differences, how do those differences compare to the variances? Variance of the data set, and can the difference be explained by variance?